There was an error on the last clip. This magnitude of r prime should be squared in the denominator here, because remember where this came from. We were simply writing out the quotient rule expression for the derivative of the unit tangent vector, and the denominator is clearly going to be the square of the denominator. We're going to get another r prime, and we're going to end up with an r prime cubed in a minute, but we're not there yet. So we have the following expressions. We have our r of t expression, our r prime of t, our r prime prime or r double prime of t, magnitude of r prime of t, and the derivative of the magnitude of r prime of t. Our curvature, as we've pointed out previously, is just going to be the magnitude of derivative of the unit tangent vector with respect to t divided by the derivative of the magnitude of the derivative of our dr dt. That's going to give us dt ds, because this is actually ds dt. So the calculation is fairly straightforward at this point. We just have to keep track of everything, and of course that's a little bit challenging. The derivative of our unit tangent vector, the expression we just looked at on the previous page, is here. Again, it's just quotient rule, f prime g minus f g prime over g squared, divided by the dr dt, magnitude of dr dt, which is just the magnitude of r prime. And you see that when we combine this with this, we are going to end up with the magnitude of r prime cubed in our denominator. So we're not going to worry too much about our denominator. We have to do some careful bookkeeping to get the numerator right. First of all, we need to do r prime prime times the magnitude of r prime. Magnitude of r prime is this expression, our r prime prime is this expression. When we multiply this expression by this expression, we're going to contribute negative pi squared a times this square root times the cosine of pi t to the I component, and similar contribution to the j component, except we're going to have a sign here, and then just this times this as our k component. Now we're also going to have I, j, and k components from this part of the expression. So I want to first write down what we're contributing from this expression to the I component, and that is, again, magnitude of r prime times r prime prime. That's going to be negative pi squared a times the square root of pi squared a squared plus 4t squared times the cosine of pi t. Now there's going to be more to it, so I'm going to close my parentheses and put an I out here. I'm going to put a big bracket out here because I'm going to have to extend my numerator over a couple of lines. And then our contribution to the j component. Well, it's just like our contribution to the I component, except where we had a cosine here, we have a sine in our r prime prime expression, so that we're going to have plus a negative pi squared a square root of pi squared a squared plus 4t squared times the sine of pi t. There's going to be more again from the second part of our numerator, but that's going to be times j. And then what times k? Well, our r prime prime just has it actually doesn't have a 2tk. In fact, the k component is just 0. And I can get rid of that, I think, with a handy domino, and we can pretend it was never there. When we take the derivative of r prime, our derivative r prime had a 2tk, and actually that doesn't all go away. The only thing that goes away is the t. So when we take the derivative of 2t, we get 2, and this expression should just be 2k. I'm going to just put a piece of paper there. Spacing doesn't look too good, but let's hope we've got that right now, so that when we do our magnitude of r prime times r prime prime, we're also going to have a plus quantity 2 square root of pi squared a squared plus 4t squared multiplied by 2. And there will be more for the k term. So what we have is the I, j, and k components of r prime prime times the magnitude of r prime. Now, I don't want to get too colorful on you here, but let's go ahead and switch colors and get the r prime times magnitude of r prime prime. R prime is this expression. Magnitude of r prime prime is just the 4t over the square root of pi squared a squared plus 4t squared. So this really is not going to be too difficult to write out. Okay, our r prime has, on the I, has a negative pi a sine of pi t, and our r prime prime has a 4t over this square root. So we're going to have what? We're going to have, let's be careful about signs, we have negative pi a multiplied by the r prime prime, which is 4t divided by the square root of pi squared a squared plus 4t squared. And that's going to be times the sine of pi t. On the j component, we're going to have a plus pi a cosine of pi t multiplied by the same. So it's going to have a structure very similar to this term, and that's just going to be plus pi a times, again, 4t over the square root of pi squared a squared plus 4t squared, but then that's going to be times the cosine of pi t. On our k component, we have a 2tk multiplied by the r prime prime, and that's going to be, and if you've noticed it already, I'll point out that I had neglected to take account of this minus sign here, so both of these signs are going to have to change. But let's go ahead and write down the k, and then we'll get the sign SIGN correct. Okay, so we have a 2tk multiplied by the 4t over the pi squared a squared plus 4t squared, and that's going to give us, well, let's write it out, 2t times 4t over the square root of pi squared a squared plus 4t squared. That'll be times rk. Now, let's go ahead and try to fix these signs, getting the pluses and minuses right. I haven't taken account of this minus sign on anything, so let's go ahead and make this one plus. Let's pull over a little piece of paper here and make this one minus. And let's do the same here. Easier to do this on a blackboard. I could simply erase the inevitable errors. In any case, I believe now that this is correct, because our r prime has a negative on the I, positives on the j and k. Our r prime prime, magnitude of r prime prime is a positive, so that we're going to have a positive and then two negatives. Now we collect this into one expression, and then we can begin to analyze it. I suppose the other thing I should do is go ahead and write in our denominator. This is our numerator. Our denominator is r prime squared, magnitude of r prime squared, times another r prime, which is going to be the magnitude of r prime cubed. R prime is this expression, the square root. So the cube is going to be the 3/2 power of the pi squared a squared plus 4t squared. So let's just go ahead and put a big old denominator here. And let's then put pi squared a squared plus 4t squared to the 3/2 power. An equal sign here. And this expression, once we check it over, make sure, should be equal to the curvature.